So as always, I'm going to record this and then throw it on YouTube. Since this is recording, you people have to keep it clean, and I mostly mean you, Mallory. You know what I'm talking about. So anyway, let's look at the schedule real quick. Whoop. So thanks, Mallory. um, so sad. There's not much time left, actually. So we only have 1 week left after this week. So today we're going to play around with the Social Security names a little bit more, and then on Monday, I want to do a final little bit of playing around with that data, and then Wednesday and Friday of next week we'll review for the final. Um, so we'll talk more about the final next week, but at this point, it's not something you should worry about, especially because it's going to look basically like your first two exams plus some of this data analysis stuff. It will look just like a couple homework problems. So there won't be anything surprising, but we can talk about that next week. So we have sort of like 1.5 days left of playing with this name data, and then we're actually just done with all the material for the course, and we'll just practice for the final Wednesday and Friday of next week. Okay, so we didn't meet on Wednesday because everybody in my house was sick. Does anybody have any lingering questions about stuff from Monday? Anything about the code from Monday or last Friday, or anything confusing you and you want to ask about it?
Yeah, when are the current like problem sets gonna be due?
Yeah, they'll be
So
due next Friday, so the very last day of class.
so all of the problem sets, so like last Wednesday, this
Yeah,
past Monday, and today will all be due next Friday.
right, because you turned in some right here, which I haven't gotten to yet. Everything
Right.
else will be due on the last day of class.
So will we have one for next Monday and next Wednesday then, or
There will be a few problems on Monday, but not for Wednesday. So at the beginning of next week, I'm going to post some review materials for the final, and we're just going to start practicing with that on Wednesday. They're not going to be formal homework, though.
right? Okay. So there's only one more problem set for this part of the course.
That's right. Yeah.
So it'll be four problem sets that are due that Friday.
Yeah, because let's see. Uh, yeah. So data analysis 3 went here. Yeah, yeah. So this one, this one, and there'll be a short problem set on Monday. Yeah. So 4 problem sets due a week from today.
Okay, cool. Thank you.
Uh-huh. Other questions on the schedule? Was that clear? Okay, so there'll be a gap day. So if today's problems or Monday's problems confuse you, then won't be due on Wednesday. They'll be due the following Friday. So as always, if you have issues on something, you should shoot me an email or show up to office hours or set up another time to meet. All the things that you can do. Okay, so let's go through some problems today. Now, I guess I should say what I've said several times before. It's always good to repeat yourself that um, if you're going to do data analysis, it's kind of a hard thing to teach because it all depends on what kind of data you're interested in, what questions you're interested in. So, again, as we've said before, none of you people, I think, are interested in, or you weren't a couple of weeks ago anyway, in Social Security baby name data. I don't know what data you're interested in, but this data set and the ones we dealt with last week, like the vaccination, the CDC spreadsheet, and these demographic spreadsheets, these are just test cases. They're just toys or something, it's just a way of getting your feet wet. So the commands we're learning can be, in principle, used on any data set as long as they're cleaned up like these are. So again, it's a little hard to teach data analysis simply because it's not clear what data you care about. But hopefully the commands we have here would let you analyze data sets you want. So let me grab the sample code. Okay, so as always, just, I don't know, just so nobody gets confused, I start from scratch. You, of course, don't have to start from scratch. And if you're asked these problems on an exam, say, like on your final, you shouldn't start from scratch, I suppose. You should already have it read in. So the second pane is just eating in all the data. And as always, my apologies to Carolyn, who has to use her own separate code. But anyway, so these two panes, I read in my libraries like always. I read in the data like always. There's nothing new here. Now, if you're not going to start from scratch, if you have your notebook already open, you may have noticed that if you leave it open for a while, sometimes the computer forgets you ran previous cells. So if this notebook has been open for a week, it may have forgotten you ran this cell. I don't know when the computer decides it's going to forget things like that. So anyway, sometimes you have to go back and rerun cells anyway. So I'm just going to feed in the data like always, and then once it's done, I'm going to ask it to show it to me. So while it's thinking about that, let me just preview what we're going to do. Oh yeah, and this is also old stuff. Okay. So now I'm just eating in all the old stuff. So the important stuff from before, this pane reads in all the data, and it keeps the states separate, keeps the states stratified. So Missouri is in there as its own thing, California's in there as its own thing, and so on. You create a gigantic data frame called data. And it's so gigantic that it takes the computer a while to do it. See, it's still thinking about it. And I don't know if you can hear it or not, but my computer is starting to run loud, right? It takes some effort. Now, in defense to my computer, I haven't shut it down in like 3 months. So I probably should have done that before class. But anyway, so you're going to create a gigantic data frame called data. And then after you do that, from data, which has, again, all the states separate, you can create a national database that doesn't care about states. You can create a national database of male names, of female names, and then just ungendered. So all the Taylors, male and female, are all combined. So as you move through the homework, or if this were on an exam or something, if I were you, I would keep these data frames all in the background separate. I wouldn't overwrite them or anything. So data for us, and these problems will just always mean all the data. And then data M will always mean national database of males, data F, national database of females, and data NG, national database of non-gendered names. Okay, wow, so it's really thinking about it. So let me just preview what we're gonna do. We're going to do some more plotting, and in particular, doing more than one plot at a time. So suppose you want to get a picture of Allen's and also Allen's, but with a different spelling. You want to see how the different spellings have grown or shrunk over time. You can plot both of those names on the same plot by basically just commanding JupyterLab to do 2 plots, but you tell it to do 2 plots all within the same cell. So that'll create 2 plots. So, oh, finally, okay. Yeah, so there's all the data. Yeah, again, 6 million rows, right? So the data is not messing around. Okay, so let me grab this now. This is new, something new. So if I just take this out, so let me just remove this for a second and run this, it's just going to do what we've seen before. Here's Allen's spelled like this over time. So Allen, spelled like A-L-L-E-N, peaked in 1950 or something with like 5,000 babies named that. So now if I put this other thing back in, I'm telling it to make 2 plots at once, but I told it that within the same cell. So it creates 2 plots at once. So it always defaults to blue is the first plot you told it, and orange is the second plot you told it. You can control the colors if you want to, but that's what it defaults to. So here's what Allen and Allen look like over time, where the blue is Allen spelled like this, and the orange is Allen spelled like that. So Allen spelled with an A used to be less popular, but then World War II somehow had an effect on the spelling of Allen's. So I don't know if there's like some celebrity around that time or something who spelled Allen that way, but Allen with an A overtook Allen with an E and really outpaced it for a while. Then they almost became equally popular back in like 1970, and then Allen with an A again created some distance. So anyway, I show this to you just to say you can create multiple plots at once if you want to. You just tell the matplotlib here, hey, make this plot and also make this plot. And as long as you're doing it within the same cell, it plots them all at the same time. And again, this code right here is from last time. That's not new. So let me pause and ask, any questions on what has happened here, how I'm grabbing this name? Again, when I say last time, I mean Monday, so it's been a few days. The group by command, this plot command, do y'all remember that from Monday? Or Friday, whatever day it was. As always, I can't see your faces, so if you're bothered by something, you have to make sure and yell about it. I also, here, I'm gonna check the chat real quick. as I've said many, many times, chat doesn't always tell me if somebody's chatting or not. Okay. So anyway, there's something you can do. You can plot two things at once. Here's another example like that. It's doing two plots at once, but it's doing the same name for two different states. This was different names or different spellings of the same name over the entire country. So here is Allen, but being plotted in Missouri and Kansas separately over time. So here the code's a little different because first I have to slice by state. I have to tell the code, hey, first of all, I care about state one, which is Missouri. And then I have to do this group by command like always. Each year is its own bucket. Each name is within each year is its own bucket, and add up however many names you see. And then, yeah, slice by the name you care about, which in this case is Allen, and then the plot command. Then these 4 lines here are the same thing. It's just I'm slicing by state 2. State 2 is Kansas. So if you want a Missouri-Kansas plot of Allen's, there you go. So they're pretty close, as you might expect, I guess. All these spikes are kind of nuts. I don't know what the deal is. I mean, I guess the data, the number is so small, you're going to see variations like this. But anyway, this is sort of cute, you know. So for the same name, you could do, let's choose states on the opposite coasts and see if they track together. As always, it defaults to blue as the first plot. So blue is California and orange is New York. So, okay, Allen with an E used to be more popular in California. Oh, sorry, used to be more popular in New York and then became more popular in California. Presumably when California started becoming more populous than New York, right? I don't know when that happened, but ooh, they almost met back here. But anyway, this height should be expected here because California is just bigger than New York. Anyway, Allen's in California crashed in the late 1980s, early 1990s or something. And there was not a similarly sized crash in New York. Anyway, so here's just something you can do. Again, maybe you don't care about this per se, but this sort of plotting is certainly useful. Okay, so this next pane, we're gonna reach back and reacquaint ourselves with an old friend, the for loop. We all liked that back in the day, didn't we? Which really does feel like a long time ago. You know, 2.5 months ago, whatever, feels like a lifetime ago. Before I grab this though, any questions on these plotting multiple plots at the same time? Okay, so suppose you want to plot over 5 states. If you want to do that, you of course could do this, like what I have here. Like you could just keep copying and pasting. So like, okay, here I'll paste, copy and paste, and now I have DF3. Like I'm already getting bored doing this, to be honest with you. But you see what I'm doing here, you know, you could do this and then have another state here. You know, this could be Ohio or something, and then you could copy and paste that and so on. So if I do that, let's just see. It's going to take it a minute. There, it made 3 plots for me. So the green one is Ohio. Now you could do that, but obviously you don't want to do that. So if you want to loop over, or you want to do this over 5 states, then instead of having the same chunk of code 5 times, recall one of the nice features of loops is that they'll let you just do the same chunk of code and then repeat it. So here I'm just going to iterate over this list of states I have. So Alaska, Alabama, these are just randomly chosen, Louisiana, Kansas, Missouri. And so what do I do for each state? Sorry, for each state, what do? I slice by the state. So when state is Alaska, I'm going to slice by that. I then just do that group by command that I had before. So group by year. I actually don't have to group by name, actually. I don't need it because I've already sliced it up here. I've already sliced by Allen's right there. And then just plot. So I just do that 5 times because there are 5 states here. So slice by the state, make each year its own bucket, add up how many names you see there, and then plot. And then this last little command here creates a little legend, because once you have more than 2 plots, it's pretty obnoxious to read without having a legend. So here are Allens over time in 5 states, although I said that and now it's not working. I'll have to go back and see why it's not working this time because it worked a week ago when I built this code. So you see this legend is obnoxiously useless. I wonder if I don't think that'll work. No, it didn't work. All right, so I'll have to figure out why it's not working today. But anyway, you can make a little legend if you want to. Yeah, this is bothersome why that's not working. But anyway, so here is Alaska is down here. The blue one actually is Alaska. It's so small. Kansas and Missouri we can probably spot. Anyway, they all look basically the same except for Alaska, which is so low. But that's because Alaska is such a small state. So generally speaking, there's like a rise and it peaks in 1955 or something, and then a crash. So down here in 2020, there's not that many of these Allens left. Anyway, so let's take that legend command out for a second. I'll have to figure out later why it's not working. So anyway, my only point with showing you this was you can loop over things if you want to. And it makes sense to do that once you got more than 2 states or more than 2 plots or whatever. So this next one, I'm not sure it's even worth showing you this because the plot it creates is so obnoxious, but it just gives you an idea of what you can do. So this plots Allens, but over all states. Okay. So as you can imagine, it's going to create at a, whoop, oh, sorry, my quotations are messed up. They got garbled somehow, so sorry. Let's fix those. So around the name Allen, there used to be like curvy quotations. You got to delete them and put in regular quotations. Anyway, so if I run this, it created the legend properly this time. All right, so that's good. And well, why is it? You know, technology is just insisting on messing up for me this semester. I don't know what the deal is. I ran this like 3 days ago and it showed me. So it is something with this scale, I guess. Allen's. Here, maybe let me make, so this said 9100. Yeah, that's why it's so tall. Maybe make this 1100, see what it does. So this number here is controlling the scale on the y-axis. Yeah, that's a little better. So no matter what you make the scale, let me make this like 500. No matter what you make the scale, this picture is going to be just a mess. So here's all Allens over all states. And here's a legend, which is not particularly helpful because there's so many plots. So again, this is just a mess. You wouldn't make this and put it in a paper or something, but it just shows you an idea of what you can do, right? You can iterate over all 50 states if you want to. You probably don't want to iterate over all 50 states to make a plot like this, but you may want to iterate over all 50 states to do something else. You know, I don't know, find the state with the most Allens or something. Anyway, so again, this is not particularly useful, but it just gives you an idea of something you can do. Okay, so anyway, so there are 4 loops for you. Okay, now the last thing I want to show you today that you'll use in the problems is, okay, proportional plots. So let me just motivate briefly what we're going to look at here for a second. So let me come back up here, pane 4, 2 plots at once. Let me remove Allen with an A and just focus on Allen with an E. So here's the rise and fall of Allen with an E. So he had his glory days back in the 1950s and then crashed. So the thing is, this plot shows raw numbers over time. So like in 1940, there were like 2,600 or something Allens born that year. In 1960, there was something like 4,500 born that year. So again, this plot just shows raw numbers over time. If you're interested in whether names are becoming more popular or less popular, the raw numbers can sometimes be a little misleading. So like right here, Allen is increasing in raw numbers, but the population of the country was also rising. There were also just more babies being born. So across this entire time span here, more and more babies are born each year because the birth rate of the US just kept increasing. So here, if you look at this upward tick here, you might just say, oh, Allen is becoming a more popular name. And it is if you're just measuring raw numbers. But relatively, it might not be more popular because it might not be keeping track with population growth. Let me check the chat real quick. Multi-state plot is missing. Oh, in the code you guys have on Moodle, is that right? Sorry, Ian, would you mind unmuting yourself just so you can tell me what?
I just noticed there's a difference between the pane 7 and pane 5.
Pane 7 and
Uh,
pane 5.
the legend code in pane 7 has .unique tagged on the bottom on the end of it.
Oh, okay. Yeah, so if that's the case, I just don't want to waste people's time, but I'm going to go after class and see if that fixes it. Yeah, that may have been my mistake. I may have garbled the copying and pasting around. So thanks. I'll just, I'll check that after class. Okay. Yeah, so anyway, here, all I'm saying is this increase might be a little deceiving. Like, sure, there are more Allens being born, but there are also lots more babies being born. So Allen might not actually be becoming more popular here in a relative sense, in a proportional sense. So all that to say, the last thing I want to show you today is how do you graph, mute, oh, there you go. Somebody's still, okay. So the last thing I want to show you today is just how would you graph the percentage or the proportion of names over time. So it's going to take me a few steps to do this. So here's the first step. You don't have to break these into steps. I just want to show you what's going on as you do them. So let's look at this first data frame I'm making here, data JN. JN stands for just names. And there was probably a better way to do that, but what are you going to do? So I group by year and name and add up the numbers as always. And then data prop, so prop is for proportional. Notice all I'm going to do is I'm going to slice by the year 1910. And for reasons that aren't worth going into now, I'm going to make sure Pandas really knows it's a data frame. So I'm starting in 1910. And then notice what is total? Total is the sum of all the numbers. So it's the total number of babies being born that year. So again, this number, there's like 50 Allens and 200 Jennifers or whatever, right? So if you add them all up using .sum, you get the total number of babies born that year. And then what is proportion? I'm making a new column called proportion. That's the raw number divided by the total. That's how I get a proportion column, or again, if you like, a fraction column, a percentage column, whatever. But again, what I'm doing is for every name, there's a certain number of instances of that name. And then I'm dividing by the total number of babies born. And here's how you calculate the total number of babies born. Just take the total number of everything and add them all up. So let me show you the data frame it makes. Okay, so in 1910, there were 111 Aarons with an AA. And here's the percentage, only 0.0215% or something. So as you might expect, given any name, even a popular name, its proportion is not going to be very big. Like, you're never going to have a name that's 30% of the baby names or 20% of the baby names. So it's all relative here, though, right? So Aaron is much more popular than, say, Abe. You can see it in the raw numbers and in the proportions, right? So Aaron was like, what is this, 4 times bigger than Abe's. But anyway, so all I'm saying is if you start with just the name data, and then this is just 1910, so I'll explain why we do 1910 in a second. You can add up all the babies born that year, create a new column consisting of proportion data by just taking the number of Aarons and divided by the total number of babies that year, number of Abrahams divided by the number of babies that year, and so on. And you create this data frame here, data prop. So let me pause here and ask, any questions on what was created here or how it was created? Okay, so now I'm going to do another for loop. And what this is going to do is, well, let's just walk through it inside the cell. So it's going to go inside the just name data frame, so not the prop. So just, again, JN means just names. So year, name, and you added up the number of names. So it's going to go in there by year, and this dot unique thing, which Ian pointed out I'm missing from somewhere else, and that will probably fix my issue from earlier. Basically what you want it to do is once it sees one 1910, like here's a 1910, you don't want it to then process this next 1910, this next 1910, and so on. Just like 1910 is a year, deal with it uniquely. Don't process each individual line. So it's kind of similar to a group by in some sense, but when you're using a for loop, it's easier to use. So anyway, I'm saying for year in these years. So the just named data frame has years 1910 all the way through 2019. So year will start at 1910, then become 1911, then 1912, all the way up to 2019. Now, I've already started building a data frame of proportions for 1910, so I don't care about that anymore. So I tell it, well, look, if year is not equal to 1910, so don't worry about 1910, I got it already. Then I'm going to slice by year. That's all. I'm not sure why I'm using an M here, to be honest with you, but I mean, it doesn't really matter. I said earlier not to overwrite data M, and now I'm doing it. It doesn't hurt the code. It's just, I don't know, I probably should have used a different name. As you can tell from all the code I've written for the course, I'm not creative with my names, so I run out of steam pretty quickly. Anyway, so I slice by year. I then do the same thing of like add up the total number of numbers I see. That gives me the total number of babies. Create a proportion column, which is the number of babies of a given name divided by the total. And then here's this concat command from a previous class. So what you're doing is you're saying, well, look, I already have this 1910 proportion data here. Now I'm just going to create the 1911 when year becomes 1911. I'm just going to create the 1911 proportion data the same way. These commands are the same. And then just concatenate it to the end of this. So that once you get to line, see how it says 1693 rows? Then row 1694 will start with the 1911 data. And then you'll build the 1911 data and then just keep going. So as year here, YR clicks through all these years, you're just creating the proportion data and concatenating. So there's a lot going on in just these 5 lines of code. Sorry, does somebody have a question?
Yeah, I was just wondering, what does the concat command do?
So it's like an append, but it's an append for these frames where like, so again, right now, this is what data prop is. So it's only year 1910. It starts at row 0 and then goes through row 1692 for a total of 1693 rows. So you could build a table that looks just like this, but with 1911 here. And then a proportion of Isabels spelled like this, you know, right here. A number of Isabels right there for 1911 though. So like way back up here, when I sliced by 1910, I could have sliced by 1911. And here, let me show you what that looks like. So here's the same proportional data frame, but with 1911 data. So there are more errands that time around. Last time there were like 111. Now there are more of them. But anyway, so all you're doing is you're giving the code like a starting point. So here's a start table, 1910. And then down here, as you let the years click through, and you don't need 1910 because you already have it. So when year's 1911, these lines of code are doing the same thing. Again, sorry, I know it's obnoxious to watch scrolling. They're just repeating these same lines of code here, but instead of a 1910 right here, there's a there's just a year, that YR variable. So when YR is 1911, there's a 1911 right here. When it's 1912, there's 1912 right there. So whatever year it is, you create, I can't, what I wanted to do is data prop right here, but I can't because then I'd overwrite my previous thing. So I'm not sure what that M I think is standing for. But anyway, so when this becomes 1911, you create the 1911 data right here, and then the 1911 data gets appended or concatenated with this table right here. So let me just actually show you. Let me comment this out. So year in 1910, first year, 1911. Let's just deal with two years. And then at the end here, I'll ask it to show me data prop. Oh, oops, I forgot my colon. When I commented out, I forgot my colon. Okay, so 1910 data is already there. And if you scroll down, see now it puts the 1911 data in there. So there was this proportion of Zach's spelled like this in 1911. and then it stops because I told it only to think about 1910, 1911. So that's what's happening here. But when I uncomment this, it's going through all the years. So if I run this and ask it to show me what it did, it's going to take it a minute because there's a lot of data, but it's going to show me, whoa, I didn't think it would do that. Oh, okay, yeah. So here's 1910, and then if you scroll all the way down, see there's like a bunch of lines. It went all the way through 2019 and tells me that in 2019, this 0.0002 thing, that's the proportion of Zyras with an H. So anyway, concat is just for every year. It's throwing that year's worth of data at the bottom of this table. It's creating it as it goes. So I may have just overkilled my answer to you, but or I may not have answered your question at all. Does that make sense, Karis?
Yeah.
Okay. Other questions on this? Okay, so let me just show you the last little thing you can do with this. So here, this is a proportional plot because I'm calling from data prop now. So I'm calling from this big table up above. It's a proportional plot of Lucille's over time. Okay, so this is what Lucille's do. Oh, wait. Oh, sorry. I'm wrong. So see how it's got this left-hand scale of numbers here. So these, of course, aren't percentages. So I was confused for a second, but I forgot that in this data frame, data prop, I kept the raw number also. So you don't have to reference back the original data frame. You can use the raw number of names if you want to. So here, see, I'm using raw number rather than proportion. So sorry, this is the rise and then fall of Lucille's in terms of raw numbers. So in 1920, there were like 8,000 Lucille's. And then by the time you get to 1980 or something, there's like 400 of them or something, not very many. So now let's create the same plot, but let's make it proportionally. So notice the only difference is there's a number right there. So a raw number. Now I'm going to graph proportions rather than raw numbers. And here's the proportional plot. So if you look at Lucille proportionally or fractionally, there's no rise and fall. There's just like a fall. There's a fall and like a leveling off, but then fall. So what's happening here? It looked like Lucille was becoming more popular for a while. And I guess it was in raw numbers terms, but the birth rate was so high back in these years. You know, there's so many babies being born that Lucille actually wasn't keeping up with just the number of babies being born. So as a fraction of the baby names being given out, Lucille was actually becoming less popular, not more popular. So all that to say, sometimes raw numbers can be a little deceiving and percentages can sort of reveal what's actually going on. Now, if the number of babies born every year was always the same, this plot would be fine to look at always. But again, like through all these years of the data, and in particular from the start through like 1980 or something, the birth rate is really high. So like, and increasing. So more and more babies being born every single year means that even though there are more Lucille's in raw number terms, as a fraction of the baby names being given out, Lucille was actually decreasing this whole time. Although it did pick back up around like 2010 or something. So you can see that pick up right there. As a fraction also it picks back up. So anyway, just here's something you could do. There are plenty of situations where raw numbers might be deceiving and you'd rather use percentages. And we've already seen that with the vote percentage data from previous days. So this is the same kind of thing. Percentages sometimes can sort of, or proportions can sometimes help show you what's really going on when things are different across counties or across states or across years with numbers of babies being born and so on. So I have this comment here that says check out names like Edna also. So here's Edna and raw numbers, same thing. Sure, it looks like it's getting more popular and then going down. But if you look at the percentage graph, see the percentage of Ednas being born every year just goes down. There's no rise and fall, just a fall. Now this data only goes back to 1910. I'm sure if we had data back to 1850, there probably would be an actual rise and fall of Ednas, but we don't have that. Donald, this is what Donald does. So here's a rise and fall of Donald's. In raw numbers, there's a peak, then a valley, then a peak. In percentage terms, there's only one peak and then down. So this crash here, this beginning crash around, what is this, 1935 or something, when my grandpa named Donald was born. Yeah, he may have been born a little earlier, but anyway, so my grandpa Donald was born in this year. It then looks like they crash but recover a little bit, but no, as a percentage, right, Donald just keeps going down. So again, this peak here is sort of deceiving because there's just way more babies being born here than over here. This is the start of the baby boom. So that peak is actually deceiving. And I think the same thing happens with Henry. As always, it's just sort of fun to play around with these things. Yeah, so here's the Henry plot. Henry making a strong comeback in the 2000s, right? So there were 15, no, what is this? Probably like 12,000 Henrys back in the heyday and made a comeback. If you look proportionally, yeah. So again, this kind of like, it looks like Henry's trying to recover here, and in raw numbers, he was trying to, but percentage-wise, it's just a crash. But then there's actually a real uptick percentage-wise starting around 2000 or whenever. So anyway, again, here's just something you can do. If you want to get both a plot of raw numbers over time, but then also a plot of percentages and compare them, you can. There are many names where this kind of exercise doesn't show you much. What's a random name? David's a random name. Here's David's rise and fall, peak in 1960 or so. If you look at the proportional plot, it shows you like the shape is slightly different. You know, this peak is actually a little fatter, but it's not revealing a whole lot to you really, unless you want to get really nitty gritty. So again, it looks like Dave is trying to recover a little bit here, but you don't really see that recovery down here because it's just more babies being born. Anyway, so a lot of the names you do, you're not going to see a marked difference, but names like Edna and Lucille, like we had, you will see. Okay, so we're now done with the bulk of playing around with this data. There's a little bit I want to do on Monday, mainly playing around with for loops, just to show you what for loops can do and reinforce them. They were super important 2 months ago. They're still pretty important now with pandas if you know how to use them properly. And I suppose I do know how to use them properly, or at least know how to use them a little bit. Okay, so now let's look at the problem set real quick. We do have some time today, and I want you guys to try your hand at a few of these. So we will go to breakout rooms for maybe 10 or 15 minutes. But as always, mainly what you should be doing is taking the code I have and see what changes should be made to it. So yeah, so we plotted, what do we plot? Allen's by different states. Here's Taylor by different genders. You could think about how to do that. It's basically the code I have. You have to think about where to make changes and what kind of changes. Different spellings of Catherine. You guys can just do that because we did different spellings of Allen. You know, most popular baby names, we did that on Monday. So this is just a callback to Monday. A proportional plot for your name, you know, and so on. So again, when you look at these, you shouldn't be writing hardly any new code from scratch, really. Maybe number 6, there's a little bit more you have to write, but for the most part, you're taking what I have and seeing if you can adapt it. Okay, so before we go to breakout rooms for like 15 minutes, are there questions, concerns on anything? All right, so I'm creating the rooms now. So if you think of something, you can let me know. We don't have a ton of time. I just want to have some individual interaction here just to see if anybody has any issues. Oop, I created one too few rooms. That's all right. Okay, so again, we'll be in this like basically just long enough for me to talk to each of you individually, and then we'll end class back in the main room.